Welcome to the Advanced Swarf Multi-Axis CAM Strategy lecture by Todd Frazee from Sierra College. In this lesson, we will explore the Advanced Swarf Multi-Axis CAM Strategy in Fusion, an enhanced technique for designed for complex machining angled surfaces with greater precision and control. The Advanced Swarf strategy allows the cutting tools side to follow intricate angled surfaces, making it ideal for challenging features such as steep walls, multi-angle geometries. Building on the basic swarf technique, the Advanced Swarf offers more flexibility with the tool axis control, toolpath smoothing, and surface alignment for high precision machining. By the end of this lesson, our objectives are for you to apply the Fusion Multi-Axis tab to apply Advanced Swarf strategy to machining shapes in 5-axis setups, to model in 5-axis CNC applications to industry standards, and apply CAM in 5-axis CNC mill applications to industry standards. The Advanced Swarf is a multi-axis strategy to machine straight-sided walls with the side of a tool. The purpose of the Advanced Swarf is to machine the walls using the whole flute length of the tool. And a common use of this strategy is to machine parts with pockets or bosses that have draft angles. The Advanced Swarf strategy is similar to the Swarf strategy, offering the following additional benefits: accurate control of the tool axis through flexible synchronization between upper and lower guide curves, and an ability to create 3, 4, and 5-axis tool paths depending on what your machine equipment capability is. The Advanced Swarf strategy requires an upper and lower guide curve to generate the tool path. Two options for the curve selection is guide curve selected from edges or surfaces. Floor surfaces can be selected so the tool can either, one, avoid the surface without hitting it, or if the checkbox is selected, it should track the floor to do a cleanup cut. Now let's apply the Advanced Swarf strategy in this Fusion CAM demonstration. This is a demonstration of the Advanced Swarf command. Now, the Advanced Swarf command is supposed to build on Swarf. It is a little more efficient when you're selecting multiple chains and locations, so if you had a part with lots of pockets. That said, I was not able to get one of the functions that seemed advantageous to work. It does work in the standard Swarf command, but the part about tracing the floor, at least at the time of this recording, does not work how the technical support says it's supposed to. So what we're going to do is I made this model. In this case, there isn't one for you to follow along with. This is a demonstration. I made a block, has a pocket. These walls have an angle on them called draft. I've already done an adaptive clearing to clear out most of the material for rendering purposes. Okay, so what we're going to do is we're going to go to setup. We're going to do a multi-axis Advanced Swarf, and I'm selecting for that tool a 1/4 inch ball mill, which has an 1/8 inch corner radius. One thing I discovered when I was working on this is, at least at the time this is recorded, the command stops going at the depth you have flute length with and doesn't give you a warning, whereas the traditional Swarf command will give you a warning that the flute's not long enough to do the work. So it took a little while to figure out why it wasn't cutting as deep as it should. But that's a little insight there. Your flute length has to be longer than whatever the wall you're trying to cut. We're going to go to 5th axis. We're going to go to tool orientation. We're going to go ahead and set it normal to our view here. And our x-axis is already where it needs to be. And then we're going to go to the geometry tab. Now the time savings on this is that the Swarf command allows you to pick a whole bunch of surfaces from multiple pockets, whereas a traditional Swarf does not. Unfortunately, it actually doesn't give you all the controls that Swarf has for angle of the tool and different features like that. So I was a little confused on that. It does require guide curves. So if we select our Swarf surfaces, which are all the ones we want to cut with the side of our end mill, it requires a guide curve at the top and bottom of your shape. This can be a little tricky on the selecting. It says you can use surfaces, but those surfaces would have to be pretty discrete to what you're cutting. So I'm going to select the top edge of my pocket as the top curve, and then you're going to go down to the lower curve, and okay, and so it looped the chain around for the bottom. So what it's going to do is it's going to use its cutting angle to average between these two chains. Now sometimes the way the chain goes, it doesn't auto select and you get to a breakpoint like this. If that happens to you, you can choose a different route, double click on the chain itself, and you can go to this open chain and it'll allow you to select individual links. And then you get to the very last gap, it won't let you select it, and you switch back to closed chain and it'll take the path you want. The first time I tried this, it actually tried to do one of the pocket sides and then the other pocket sides. Okay, so we got that. Now floors. One of the advantages of what they say in the documentation is select the floors and it should automatically trace them. So like to go over this hump here, it should automatically trace the floor by selecting this tracks floor icon or checkbox, which you can see here. You know, if it's deselected, it's supposed to come down to a certain level and stop cutting. Whereas if it says selected, it should follow almost like a pencil mill the floor. At least the time this is recording, it does not work. Okay, so you can select your model if you want to for gouging protection, and then you can put in offsets if you want to give clearance, and that's something the traditional Swarf does not allow you to do. Okay, so we're going to go to heights. Everything's automatically selected. We're going to go on to passes. Just like Swarf, you can do multiple depths and you can do multiple passes. So multiple passes would be horizontal passes, going around extra loops to remove material. You can choose which path you want to follow, lower or upper. Guide path curve, it'll trace that one closer. So I put lower guide curve because I have this curvature here. I want to make sure that it's following that. Let's go down to multiple depths, and it defaults to blend top and bottom, which is supposed to make each step a variation of each other. And then you can just, or you can have it start at the top and go down, or start at the bottom and come up. I don't know why you would do the second one. Sounds like that would break a tool. Okay. So let's leave it at the default, see what happens. We're going to do automatic step downs. I'm just going to leave it at 40,000 observation purposes. Smoothing, I would put this on, but it should be 4/10, not 2/1000. And you can check the gouge checking. It's going to mainly check that your holder is not interfering with anything. Okay, let's hit OK. Processes for a second, and here you go. So, but in theory, with that box I selected, it should have done a final pass tracing the entire floor of this pocket, and it did not do that. So yeah, I may have a parameter off, but that is in a nutshell the difference between Swarf and Advanced Swarf. Now, if I were to overlay a Swarf command as an alternative, here is a traditional Swarf, similar settings, and as you can see, the very last path actually traced over the floor and across the hump there to give you a nice clean trace. So I don't know, you can make your own choices. In my opinion, I would just stick with Swarf for now, since there doesn't seem to be a huge advantage to using Advanced Swarf. Alright, I hope this was helpful. We'll catch you on the next one. Hopefully that demonstration was successful for you, and we will move on to in summary. In summary of this lesson, we explored the Advanced Swarf Multi-Axis CAM strategy in Fusion and enhanced technique for design for machining complex angled surfaces with greater precision and control. The Advanced Swarf strategy allows the cutting tool's side to follow intricate and angled surfaces, making it ideal for challenging features such as steep walls, turbine blades, and multi-angled geometries. Building on the basic swarf technique, Advanced Swarf offers more flexibility with tool axis control, toolpath smoothing, and surface alignment for high precision machining. In conclusion, by the end of this lesson, you are able to apply Fusion Multi-Axis tab to apply the Advanced Swarf strategy to machine shapes in 5-axis setups. You're able to model CAM in 5-axis CNC mill applications to industry standards, and apply CAM in 5-axis CNC mill applications to industry standards. This concludes this lecture, and we'll see you on the next one.